What is rectification? The reason I'm asking that is because you'll often hear about potassium channels which are rectifying, either inwardly or outwardly. Not just potassium channels, other channels do it as well. So let me just explain that step by step. If you start with, let's look at it from the point of view of physics. Right? So imagine that you've got a battery and you've got a resistor here. What's going to happen is the current's going to flow through the resistor, and battery has a voltage, the resistor has a resistance, and you find that V equals the voltage equals the current times the resistance. If you're familiar with physics, you've done this before, but if you're not familiar with this, this is Ohm's law, and it basically tells you that for a certain resistance in a circuit, the current flowing through that resistance is directly proportional to the voltage. So if I double the voltage, I'll double the current. If I half the voltage, I'll half the current. And, crucially, if I swap this around to point the other way, the current now is going to go in the opposite direction. But it'll be the same in magnitude, regardless of the direction. So in other words, if I were to plot the voltage of the battery against the current going through the resistor, I would have a dead straight line. Really simple. Okay, now what I'm going to do now is I'm going to use a slightly more magical resistor which itself detects the voltage and changes its own value. Right, so what it does is it only allows the current to go in one direction. In this case, if the voltage is, shall we say, negative, what we find is it allows the current to pass through. But if I now switch the voltage the other way round, so the current wants to go that way, it doesn't let it. It only lets the current go in one direction. So this is called rectification. What it means is, if I were to try and apply a voltage, an alternating current like this, just like you get on the mains, if I were to put that through this rectifying resistor here, this red one, what I would get would be that. It's only allowing the current to go in one direction. Now we have exactly the same, we have a very similar thing in neurons, in which case what we've got is a membrane. So here's my cell, and I've got a current, a channel, which is rectifying. Let's say, do you remember we said we've got high potassium on the inside, low potassium on the outside, and this ion channel will allow potassium only to go inwards. It only allows potassium to go that way. It's a bit like this one here. Now, we need to modify this a bit, so remember that, in fact, because of the equilibrium, but because of this difference in distribution of potassium channels, if I were to have an ion channel which is open all the time, which is non-rectifying, so blue is non-rectifying, I would have a line like this which goes through EK. right? Because we've already got a voltage offset because of this distribution of potassium. Right? So this is just like the classical leak channel. Now, if I introduce some bit of magic down here so that it now becomes rectifying, let's say that we only allow potassium to go in, what we find is we would have this kind of voltage current relationship like that. So that's what rectification is, and the way these ion channels, you think, well, how on earth do they only allow potassium to go one way? It's actually really simple, and that is to make sure that your close closed, how do you spell closed? Closed at positive membrane potentials, because then what would happen is you would have a linear relationship while you're open, and then suddenly you close again and you get that. And this pattern here is what you get in rectifying channels.